Okay, hi guys. So in this lecture, we'll be summarizing by seeing the reactivity of each carbonyl compound with the all the different tests which we studied during the course of this concepts, the carbonyl compounds concepts. Okay, so we have compounds. Okay, we will test it with tolerance test. Okay, with the Fehling solutions. Okay, with the Benedict solution. Benedict solution with 2,4-DNP. Okay, with Schiff's base, with Schiff's reagent, with NaOI, and finally with NaHSO3. So I'm writing NaHSO3. So let me rewrite with some adjustment in space. Schiff's base, Schiff's base and reagent. And then we have NaOI, and finally we have NaHSO3. Okay, so let's get started. So let me write down the compounds now. So compounds are, let's say we have first one as Sc double bond OH. Okay, it's a aldehyde. Aldehyde will give positive test for tolerance. Okay, will give positive for Fehling, will give positive for Benedict. Okay, for those who are thinking we have not discussed Benedict solution, yes, you are right. We have not discussed Benedict solution and will not also go into the details of it. You can just remember that how will the Benedicts react towards different, or how the aldehydes and ketones will react towards Benedicts. The answer remains the same as toluenes. Okay, whatever is the nature of the reaction of aldehyde or ketone with toluenes reagent, that would be same with Benedict solution as well. Okay, so if it is a tick here, it will be a tick here. If it is a cross here, it will be a cross here. Okay, Benedicts acts the same way as toluenes reagent. Okay, 2,4-DNP, yes, every aldehyde ketone shows 2,4-DNP. Okay, Schiff's base, yes, every aldehyde ketone shows Schiff's base. Schiff's reagent, para-rosaniline, only aldehydes will show. NaOI, NaOI is nothing but, I won't tell you in this lecture. I hope we have discussed much about NaOI. Okay, so it will not show NaOI. Okay, and finally for NaHSO3, yes, it will show reaction with NaHSO3. Okay, we have discussed about NaHSO3 in the last lecture only, so it won't be a problem. Okay, so NaOI is obviously used for iodoform test. Okay, where CHI3 yellow colored precipitate will form. I'll just reiterate for the benefit of the all. Okay, so we have CH3, CHO. Will it give tolerance? Yes. Okay, let me first write all the compounds. Okay, so PSCHO, we have something like this, and finally we have, let me draw it here, we will have something like this. Okay, so let's discuss them. So for this compound, okay, so for toluenes gives positive test only for aldehydes, not for ketone. Okay, so ketone, it would be no. Okay, so it would be no for a ketone, and for the rest of them it would be yes. Okay, what about Fehling? Fehling again gives test only for aldehyde except benzaldehyde. Okay, so benzaldehyde, it will not show Fehling test, and ketones will also not show Fehling test. Only aldehydes will show apart from benzaldehyde. Okay, what about Benedict solution? Benedict would be same as Tollins. So Chris, if it's tick here, it will be tick here, cross here, tick tick, cross. It behaves the same way as Tollins. What about 2,4-DNP? 2,4-DNP doesn't care whether it's a aldehyde or ketone. It would give positive test for all. Roy color precipitate will be formed. What about Schiff's base? Schiff's base again would be formed for all. Okay, because every compound has a C double bond O group in it, so it can form a imine. Okay, what about Schiff's reagent? Schiff's reagent again will not act with aldehyde, it will only act with ketones. Okay, what about NaOH? Haloform test. Haloform test requires 2 hydrogen atoms to be removed from the carbon atom, neighboring carbon atom, so it cannot be possible in this compound. What about this compound? It is still not possible in this compound. Why is it not possible? Oh, sorry, not 2 hydrogen, it should have 3 hydrogen, because all the 3 hydrogens of the alpha carbon will be replaced by the X or the halogen atom. Okay, so it will not be possible for this. Again, for this compound it is not possible. Okay, for benzaldehyde again it's not possible. Okay, for CH3CHO it is always possible. Okay, and for this compound it is possible, right? Because it has this CH3 group, okay, which has 3 alpha hydrogens. Okay, so it would be possible for this compound. What about reaction with NaHSO3? Reaction with NaHSO3, as we saw in the last lecture, will not be possible for compounds which are not either aldehyde or ketones with methyl group attached on both the sides. Okay, so it would be possible for all the aldehydes and ketones. It would not be possible here. It would not be possible because it is not a methyl ketone. This compound is a methyl ketone. Okay, this is the methyl ketone. I think I might have said that methyl groups on both the sides, so it is wrong. Methyl group is, by the meaning of methyl group, it should have a methyl at least on one side of the keto group. Okay, so it is possible in this case. Okay, so let's summarize it. So what we have in the end is we have first Tollins. Tollins actually gives positive test for aldehydes and ketones. No, it doesn't give positive test for ketones. What about Fehling? Fehling gives test for all aldehydes except benzaldehyde or PHCHO. Okay, and for ketones again it does not give. Okay, for Benedict same as Tollins. Next we have 2,4-DNP, aldehydes and ketones. It gives positive test with both. Okay, what about Schiff's base? Again it gives for both. Okay, what about NaHSO, Schiff's reagent rather? Pararosaniline with SO2 plus HCl. It would give only for aldehyde, not for ketones. And for NaHSO3 it will give for again aldehydes and ketones. No, it won't give for ketones except methyl ketone. Okay, except methyl ketone. Okay, so with this we come to an end of the concepts of carbonyl compounds. From the next chapter or from the next lecture onward, we'll be discussing on carbohydrates, which will be our next concepts in the series of organic chemistry lectures. Okay, so till then, good luck and goodbye.